Good afternoon, my dear student. Good afternoon, my dear student. Your physics class, continue with your previous class. Current electricity completed. Current electricity completed. Next chapter, magnetic effect of electric current, magnetism. Magnetic effects of electric and magnetism. So, my dear student, the last chapter good afternoon, anyone student, good afternoon. You are here to me, you are hear me. So, yes, magnetism, magnetic effects of electric current. This is the last chapter of your syllabus for 2021. Okay, but the last part, that means the sources of energy, you see the NCERT book, it is not in your syllabus for this year. So, my dear student, I try to clear your practicals for today, and any queries from your last chapter means current electricity, any numerical energy, any problem from your side, you discuss it. Okay, you discuss it. But today I also try to clear your practicals. You write in the practicals in your copy. That means I also try to clear you. First, start with the name of the practicals, experiment, or object of the next, the theory. Binding copy, maybe the trade copy. Have you note it? Okay. So you check it. You write it from your net service. Okay. Net service. The aim of this experiment. Suppose first experiment, Ohm's law. Ohm's experiment. That means you prove the Ohm's law first. According to your syllabus, it in this method from your syllabus, according to your syllabus. You write it in this method. Sound is clear? My dear students, sound is clear. The studying the dependence of potential difference, studying the dependence of potential difference across a resistor on the current means potential versus current. Potential versus current. Potential versus current means potential difference versus current. That means the Ohm's law. You know it. Temperature, other physical conditions remain constant. Remain constant. That time the potential difference in the 2 points of the conductor is directly proportional to the strength of its current. Okay, so this is the Ohm's law. You verify it with the help of the experiment. Means circuit, electric circuit. You know it. This is the electric circuit for Ohm's experiment. You know it. So from this instrument you can find out the V and I. Means you control the current with the help of the rheostat, and rheostat control the current. So current versus potential, you plot it. You note it. Okay, and then you plot it in a graph paper. Then you plot it in a graph paper. That means if you wish, you write it this INT, observation serial number 1, 2, 3, 4, this way. And you find out the value of R, and then you find out the value of W. Okay, so this is the observation table. So you note it, I and V from your instrument, not you note it from your net service. All things you note it from your net service, but you write it the observation table, but it will not fill up from the net service. You collect the data from your experiment. When you will come in your practical room, that time you collect the data from your experiment and you write it, the data, and then you calculate the resistance and average resistance. This is the practical, and with the help of this practical, you plot the graph, V versus I. Okay, and you put in the data, so many data are there, minimum 5 data or 4 data. Okay, so you see the two points are on the line, and the 0, 0 line also points, and the rest of the 3 points above and below the line. This is the line. Then after this, you choose a point on the line, except the experimental data. Except the experimental data. Suppose you consider a point here, you draw a perpendicular line on it. This value is the V, that value is the I. So you can find out the value of V by I. This is the resistor. This is the resistance of the resistor. This is the resistance of the resistor. But you had written at the 2, it's not clear. Can you repeat? Okay, you see the experiment number 1 means you note it, this studying a dependence of potential difference across a resistor on the current passing through it and determine its resistance, and also plotting a graph between V and I. Okay, so this is the practical aim of the practical, and the name of the instrument is Ohm's instrument. Okay, so you note it first, aim of the experiment, this line, two lines, and then theory of this. Theory means Ohm's law. You write it here. Then apparatus required: 1 voltmeter, 1 ammeter, 1 rheostat, 1 resistance, 1 key, 1 battery, and connecting, insulated connecting. Next is the observation table. It is the observation table. You write it, the observation table, table number 1, serial number, I means ammeter reading, voltmeter reading, you write it. Ammeter reading and voltmeter reading, you note it from your practical data. You blank it. When you will come your practical notes, then you note it from your experiment, and you write it and you calculate it. Am I clear, yes or no? Am I clear, yes or no? Okay, so first is the aim of the experiment, second is the theory of the experiment. When you will come to your school and you complete the practical, then you submit it. But suppose your school will be open November, suppose, and your exam will be start February. So that time you will be more tense. So before it, you note it only the rest of the part except the observation table data. Am I clear? Except the observation table data, all the parts means all the points you note it in your copy. When you will come in your school and in your practical, that time you will complete the practical in one day, 1 or 2 practicals. So after this you submit it. Okay. So my dear student, you check it. The first is the aim of the experiment, second is the theory of the experiment, third is the apparatus required, fourth is the procedure as you wish you note it, fifth is the observation table. Observation table. Observation table, table number 1. Before it, you write it, the ammeter range, voltmeter range, list of the ammeter, list of the voltmeter reading. So many terms are there. You see in your books or the name, you collect the experiment, and those are the constant terms. Different school practicals, you see the apparatus range will be the different. So you only write it. The range of the voltmeter equal to dash. Range of the ammeter equal to dash. Least count of the voltmeter equal to that. List of the ammeter equal to dash. And zero error of the voltmeter, zero error of the ammeter, it also be the 0. Okay, so this is the constant term. Next is the observation table. You write it. And with the help of the graph, you find out the value of R. Okay, and you write it at the point of result. The resistance of the resistor is equal to that value from the graph, that value. Okay, next is the frequency, and after it, the sources of energy. You notice the 2 points for frequency and 2 points for sources of energy. Okay, my dear student. Next, This is the first experiment. Second experiment. Experiment number 2. Experiment number 2. Experiment number 2. Determine the focal length. Focal length. First one is the concave mirror, and second one is the convex lens. Okay, concave mirror and convex lens. Concave mirror and convex lens. You check here, determine the focal length, concave mirror and the convex lens by obtaining the image of a distant object. Distant object. So, you know it with the help of the convex lens. How can we find out the focal length of the convex lens? Suppose you consider it at the noon. The sun is top of it, means on your head. So with the help of the convex lens, you point sharp point on the paper. With the help of the convex lens, the image of the sun, that means a sharp point on the paper. And you check it, the paper will be barred. Paper will be barred. That time, this is the focal length, means the rough focal length of the convex lens. Am I clear? Sir, you check it. So, so, suppose you consider you hold a convex lens and the image of the sun is a distinct object. As image of the sun, you see on the paper, a sharp image is created on the sun, on the paper, and the paper will be burned. That is the focal length. That is the focal length of the convex mirror. Someone had muted you. What is that? You have been muted by someone has muted you. You cannot hear. Sir, you have been okay. So, this is the method for the rough focal length of the convex lens. But, my dear student, with the help of the optical bench in your practical room, you see or you find out the focal length of the convex lens. That is the actual focal length of the convex lens with the help of the optical bench. But with the help of this, that method is the rough focal length of the convex lens. Similar way, a rough focal length of the concave mirror. Suppose you are standing on a window and you open the window, you see a tree far distance from the window. And with the help of the concave mirror, you put the concave mirror on a scale. Okay? And a piece of paper you hold on the scale, or move it the mirror on the scale, and a sharp image will form on the wall or the paper. That means a real image form on the screen. That is the focal length of the rough focal length of the concave mirror. The rough focal length of the concave mirror, but with the help of the optical bench, you can find out the actual focal length of the concave mirror. And you note it in the same method. First you write in the aim of the experiment, second you theory of the experiment, apparatus required, and the observation table, calculation, result, equation, and sources of error. Next practical. So practical number 2. Practical number 3. With the help of the glass slab. Theory portion you already know it. Tracing the path of a ray of light passing through a rectangular glass. Suppose tracing a path of a ray of light passing through a rectangular glass slab for different angles of incidence. Different angle of incidence. Measure the angle of incidence, angle of refraction, angle of emergence, and interpret the result. Okay. So my dear students, you first consider a normal line drawn on the surface, and you measure with the help of the protector. The angle of incidence is equal to 45 degrees, and two pins are put on the line. Okay, two pins are put on the line. Suppose you see from the opposite surface, with the help of your eye, you block the one eye, and with the help of the another eye, you see the one pin, means third number pin. The bottom of this third number pin will guard the first and second number. With the help of your eye, you see the opposite surface, the number third pin guards the first and second pin. And the fourth pin also guards the first, second and third pins. That means after this, you remove it from the paper and you draw a perpendicular on the line, and this is the refracted ray, and that is the emergent ray. That is the emergent ray. So after this, you check it. This is the angle of incidence I, that is the angle of emergence E, that is the angle of refraction R. That also be the same because both are perpendicular on it. That also the R. After this, you check it. This angle and that angle are equal. With the help of the data from your practical, with the help of the protector also, you see this angle and that angle are equal. If this and that angle are equal, you can say, suppose this is the PQRS, PQ parallel R means angle of, incident ray and the emergent ray both are parallel. Both are parallel. And in angle of incidence equal to angle of emergent. Okay? Next, you find out the refractive index. The refractive index of the glass. This is the glass. Sin I by sin R. So sin I means, you know this angle is 40 degree or 45 degree. You choose it at your risk, 45 degree, and you measure the angle of refraction with the help of the protector. That value will be sin of, suppose less than 45 degrees, that means suppose 30. Suppose it is not this. It is so less than 45 degrees. It must be less than 45 degrees. So my dear student, that value must be greater than. So you can find out the refractive index of the glass, and you can verify the angle of incidence equal to angle of emergence. You can prove it, the incident ray and the emergent ray both are parallel. Okay, this is the third practical. And fourth practical is tracing the path of ray of light, tracing the path of ray of light through the glass prism. Through the glass prism. Number fourth is tracing the path of ray of light through the glass prism. Suppose this is a glass prism. You draw a perpendicular line on it, and you draw a line, angle of incidence is going to suppose 35 degrees. Okay, and you see, you put the two pins on the line, and see from the opposite refracting surface, the third number pin block the first and second number. And fourth number pins also block the first, second, third number pin. You see with the help of your one eye, when you block the one eye and you remove it, you draw the perpendicular on it, and this is the emergent ray. So you extended the angle of the incident ray and emergent ray, that is the angle of deviation. You know this angle of deviation equal to this I1 plus I2 minus A. So you can find out in the delta, and if you wish to find out the value of refractive index is equal to sin I by sin I. So the two formula you verify it with the help of this formula. So my dear student, you check it, you note it in your copy from the net or your books, but you cannot write it the data from your net or your books. You write this data from your practical books, and after this you calculate it, and then you submit your paper. So my dear student, thank you. See you again next day.